Namaskar. I am Harsh Sahani. On behalf of Tata Motors, I am pleased to announce and introduce a new potential line. Let's understand about this product line in detail through this effective video.
Every post-warranty Tata Motors commercial vehicle's journey begins with one simple step, that is starting the engine, because a smooth start ensures a smooth journey. But have you wondered what ensures a smooth start of a post-warranty commercial vehicle engine? It's the Durafit starter motor. Before we take a look at the Durafit starter motor, let's understand what a starter motor is. A starter motor is one of the major components used in an internal combustion engine that is electrically powered. It helps initiate the engine that runs further using its own power. Now let's see how a starter motor works. In modern engines, a flywheel is connected at the rear part of the engine with several teeth around its perimeter. The starter motor is placed in close proximity with the flywheel. When the engine is started, the starter motor connects itself to the flywheel and forces it to rotate, further enabling the crankshaft to move and push the pistons, starting the combustion process. The starter motor then disconnects itself from the flywheel, letting the engine run on its own. The starter motor has a fairly small pinion gear that is needed to run at a high speed to ensure movement in the much larger flywheel. It also requires a high torque to allow movement in the crankshaft. The starter motor requires a large current wave that often drains the battery. In this case, the battery is recharged by the alternator. Now let's take a look at different parts of the starter motor. On the top of a starter motor, you will find a solenoid which has electrical connections at the back. A thick electrical wire runs down into the main case that stores the electrical motor. The main case has a removable plate at the rear. The drive end frame holds all the parts together and also helps in mounting the motor in the car. In the front, the starter motor has a shield that covers the pinion gear partially. Inside the device, there is a shaft that runs through the starter motor which has a rotor attached to it. The rotor is also called the armature which moves the shaft. The rotor has several channels cut into it where each channel has coils of thick enameled wires. The ends of these wires connect to the commutator plates which are segments of copper that are separated and insulated from each other while being spaced out on the circumference of the rotor. At the end of the motor, there are spring-loaded brushes that push against the commutator plates. These slide across the commutator plate which allows electricity to flow into the rotor. Permanent magnets surround the rotor and are attached to the case forming the stator. Some models of starter motor use field windings that are coils of wire that create an electromagnetic field when it comes in connection with power. Permanent magnets and field windings with electromagnetic power essentially do the same job, but the field windings have a more complex design and can create a stronger magnetic field. When electricity flows through the rotor, it flows through the brush, then through the coil to the opposite brush and then returns to the battery via the frame of a car. When the current flows through a wire, it generates an electromagnetic field. As we know that magnets interact by pushing and pulling each other, so the rotor's electromagnetic field is repulsed by the stator's magnetic field. The gaps in the commutator help in resetting the magnetic field, keeping the rotor from getting aligned. There are usually two pairs of brushes and multiple commutator plates that activate at the same time. This activation ensures a strong magnetic field and smooth rotation. A thick wire runs from the brushes to the solenoid. Within the solenoid is an iron piston that moves backwards and forwards. This is surrounded by a solenoid coil, which is a coil made of enameled wire. When the solenoid coil is energized, it creates an electromagnetic field and attracts the iron piston, pulling it backwards. There is a return spring present in between the solenoid and the end of the piston, which helps the piston to return to its original position when the solenoid is de-energized. The end of the piston has a contractor plate. When the piston comes back, it comes in contact with the main electrical terminals mounted on the rear of the solenoid. Once the contact happens, a very large and strong flow of electric current reaches the brush and powers the motor. When the coil is de-energized, it will cut the power to the motor also. The front end of a piston connects to a lever. When the piston moves backwards and forwards, the lever pivots. The lever is connected to the drive sleeve and an overrunning clutch sits ahead of this. The pinion gear is attached to this at the front of the shaft. The overrunning clutch protects the electrical motor. Inside the clutch are a number of rollers with springs that move back and forth in a tapered notch. When the pinion starts to turn, the rollers move to the end of the chambers and wedge in between the pinion gears, locking it into place. This allows it to rotate the flywheel. After a short time, the combustion of the engine causes the flywheel to rotate faster and the rollers to disconnect, allowing the pinion to rotate freely. The overrunning clutch rides along a spline on the shaft, allowing the pinion gear to slightly rotate, which locks the rollers and allows it to slide easily into the flywheel. When the ignition is turned, it causes a smooth current of electricity to flow into the solenoid coil. The solenoid is made of two coils that are the pull-in coil and the hold-in coil. The end of the hold-in coil connects to the casing of the starter motor. The current returns to the battery via the frame of the vehicle. The pull-in coil is connected to the main output terminal. Both coils are energized to create a strong magnetic field that pulls the piston back. As the piston moves back, it is going to pull on the lever which transfers the motion to the drive sleeve, pushing it forwards. As it moves forward, it slightly rotates the pinion, allowing it to lock the rollers in a clutch and slide the pinion into the flywheel. The coil produces an electromagnetic field that interacts with the permanent magnet or field winding in the stator. This causes the armature or rotor to rotate faster, leading to a high torque. The rotor transfers this through the shaft, through the clutch and into the pinion gear, which turns the flywheel. As the flywheel starts the combustion process, the engine will begin to rotate the flywheel faster in the starter motor, which unlocks the overrunning clutch so that the pinion gear springs freely. When the key is released, it casts the power to the solenoid coil, which releases the piston. The spring pushes the lever back, removing the pinion gear from the flywheel. The current is cut through the starter motor. The combustion engine continues to run by itself. The Durafit starter motor is a super quality product that ensures a strong start for your journey. It is one of the most powerful starter motors in the market. It is a perfect fit for the Tata Ace and Tata Magic. At Tata Motors, we understand what's best for your vehicle, and here are a few reasons why you should choose the Tata Motors Durafit Parts starter motor. Made of high quality material, anti-corrosive, tested for 100% performance and quality, tested for 30,000 cycles, easy to service and low maintenance. Tata Motors is constantly working towards making every journey smooth. We are soon coming up with air bellows and alternators as well, which will provide a more powerful start to your journey. As we provide you with a wide range of products and services at every step of your journey, you can put your trust in Tata Motors and ensure peace of mind on every drive.